Hello, this is Susan Poss at Spartanburg Community College, and today I wanted to talk with you about how we write equations for parallel and perpendicular lines. And just a quick refresher, remember parallel lines have the same slope because they never cross, they never intersect, and perpendicular lines have slopes that are what I call negative reciprocals. When you multiply them together, they produce a -1. So let's say the first slope of a line is positive 2/3. Then a line perpendicular to that would have an opposite sign and a reciprocal number. Okay, so here's our first example. Write an equation for a line parallel, so I've highlighted that, parallel to the line -5x minus 5y is equal to 8, and through the point 2, -1, put the equation in slope-intercept form. This is a pretty difficult problem, so I wanted to start off by trying to get you a little drawing of what's going on here so you can sort of piece together the different little bits of information. So I'm going to sketch in a quick grid. I'm going to take the equation and I'm going to solve it explicitly for y. So I'm adding 5x to both sides, and then I'm dividing by -5. So I can see that the slope of this line is going to be -1, and I can see that the y-intercept is at 0, -8/5, or if you want to put that into mixed number form, it's -1 3/5. So I can't do a real good job with this, but I wanted to give you an estimate of what this looks like. There's the y-intercept at -1 3/5, and then I want to show you a slope of -1. So I'm counting down 1 and right 1, down 1 and right 1. So a rough sketch of this line looks something like that. And then we've got this point, 2, -1. So out to about like this and down to -1. So what are we doing? We've got this line, which we've graphed from this equation, and we've got this point. And we're being asked to write an equation for another line, and it's this blue line that runs through that point to -1 and is also at the same time parallel to that first line that I've graphed for you there in green. So this is how you put all the pieces together. The slope of the first line in green is -1. And since they are parallel to each other, that means that the slope of the second line is also -1. Let me do subscripts here so we can track which goes with the first line and which goes with the second line. So now the blue line, I have two pieces of information. That's all I need. I've got a point and I've got the slope. So can I write the equation for the line? Yes, I can. It requires that I squeeze in here that point slope formula that we talked about in some earlier conversations. You write down the y, you write down the minus, you pick up the y coordinate of the point. The slope we've determined has to be -1 in order to make it parallel to the green line. And then write down the x, write down the minus, and pick up the x coordinate, which is 2. So I'm about to actually have the equation now. I'm just putting it in a little bit better form for you. Multiplying here by -1 over that second parentheses and solving explicitly for the letter y. I'm subtracting 1 from both sides. Whoops, that's not what I meant to write. So this is the equation for the blue line. And that blue line meets these two conditions, that That blue line is running parallel to the green line that was given to me in this equation, and it passes through the point to -1. And the last thing I always like to do when I'm looking at these is obviously the slope is -1. I like to look at this y coordinate and go over here and just look at my sketch and see if my rough sketch looks like that y-intercept at 0, 1 is matching up with what I see there in my sketch. And I'm happy with that, so I think that looks fine. Let me skip this next example and scroll down, and let's take a look at things that are perpendicular. And this is also special because I'm dealing with a vertical line here. So a couple of things to refresh your memory on. X equals 4 is the equation, and you can see that that graphs here as a vertical line. Remember the slope of all vertical lines. Are undefined. Okay, so I'm trying now to draw a line. Here's the existing line, x equals 4, vertical line. I'm trying to draw a line that's perpendicular to that. So perpendicular, remember, crosses at a 90-degree angle. The lines cross and they meet in here to form these two 90-degree angles. And that line must also pass through this point that has coordinates 5, 5. Okay, so what do we know about the slopes of horizontal lines? So there's a lot to remember here. I'm going back and picking up a lot of information from some past exercises that you have done. So for all horizontal lines, the slope is equal to 0. Okay, so I'm trying to write this equation. Remember, that was our goal, is to write an equation for this green line. So here I go with my formula that I've used over and over again. I'm picking up the y-coordinate from the point. I'm picking up the slope for a horizontal line, which is 0, and I'm picking up the x-coordinate from the point. So again, when you multiply by 0 over here, everything zeroes out, and you end up with a horizontal line. The equation looks like that, y equals 5. So you may have some exercises with both horizontal and vertical lines. You'll just have to be very careful with those. All horizontal lines take the form y equals a number. And eventually you might even learn to take a shortcut. You can see that the y-coordinate here was 5, and the equation turned out to be y equals 5. So those are things you can observe as you work. I have, I think, one more example for you. Yes, one more example for you. This last one, we're going to find the equation for the line that passes through the point 4, -3, and is perpendicular to, so that's an important word there, the line with this equation, y minus 1 equals 3/4 x plus parentheses x plus 1. So let me take this equation, and I want to show you that the slope of this first line is equal to 3/4. Let's go over here and do a quick sketch of this again so you can see what's happening here. So my point here is the opposite of 1 and the opposite of -1. So if you will remember from point slope, this is identifying the x-coordinate and the y-coordinate opposite signs. So let me plot -1, 1, which is right about there. And then I'm going to show you a slope of up 3 over 1, 2, 3, 4. So this line looks something like that. Let me change color for us here. All right, so now I have this point, -4, -3. 1, 2, 3, 4, 1, 2, 3. It looks something like that. And I'm trying to figure out an equation for a line that passes through this point and runs perpendicular. So as my rough sketch looks something like that. Here's my 90-degree angle. It's passing through this point. And I know that the slope of the green line is 3/4. So what is the slope of this red line? That slope has to be the opposite sign, so negative, and the reciprocal number. So the slope of that second line is going to be negative 4/3. Okay, so I think we're ready to put it all together. This is using point slope again. Remember, you want to use the point that's in red here because we're going for the equation of this red line. So y minus, pick up the y coordinate here, which is -3. The slope in red is negative 4/3. X minus, and pick up the x coordinate, which is -4. So this becomes y plus 3. This becomes x plus 4. And so we have an equation right there. If we want to go ahead and put it in slope-intercept form, let me do a couple more steps. I'll distribute the 4/3. It doesn't look much like a 4, does it? Let's change that so it looks a little better. So negative 4/3 times positive 4 is negative 16/3. And I'm running out of space. Hold on. It's acting weird. There we go. So on this last line, I'm subtracting 3 from both sides. And you've seen me do this before. I've got to get everything into the common denominator 3 here so that I can combine those last two terms. All right, so finishing up, I'm down into the next problem, which I'm not going to work. This is negative 9/3 and negative 16/3, which is negative 25/3. So I've got it in the proper form. Let me show you one last thing that I mentioned earlier that I always like to go back and check to see if it makes common sense. Is that right? Yes, 8 1/3 negative. So does it look like, if I extended this red line on my grid here, does it look like it might cross down here at negative 8 1/3? And it does. So I'm happy with the way that turns out. And of course my slope here is negative 4/3, which is the reciprocal, negative reciprocal of positive 3/4. So I think that's a good place to stop. Working with equations for parallel and perpendicular lines.